Can you all see my screen? Hello?
Yes. Yes.
If you can see my screen, let me see. Can you give me a thumb up, please? If you can see my screen.
Yes,
yes. I'm recording.
Yes,
Yes. Good.
Yes.
Beautiful. Thank you. So, like I said earlier, we are starting from the basics. What is data? Data analytics, classes of data, types of data, data collection, data cleansing, data analysis, data storytelling, data visualization. So we are going to be dealing with that from the basis. So the very first one is data. We want to talk about data. Data. So the first question is, what is data? What is data? It's not the data that I use to browse the internet. Data is a collection of facts that can be used to draw conclusions, make predictions, and assist in effective decision-making. It is a collection of facts that can be used to draw conclusions, make predictions, and assist in effective decision-making. I don't know if you have any statistician in the house. I don't know if you have any statistician in the house. Do we? No. I remember when I was in UI, our motto is facts from figures. I love figures. I love figures. There's this quote that says you can have information without data, but there's no how you have data without information. The information you have without data could lead to error. It could be somebody said, but when you have the data, when you have the statistics, then you can say, like one of the errors in statistics is generalization. People will just come up and say maybe over 60% of Nigerians, they are jobless. Or like somebody once said the other time, the youths are lazy. That's generalization. It's not fact, because he just said it without getting the information from the data. So I move on to the next slide. Data can be text. Data can be numbers. Data can be videos. Data can be documents. It can be audio recording, and it can as well be transcripts. These are all forms of data. You can get your data from text. You can get it from numbers. You can get it from videos. You can get it from documents, audio recording, and transcripts. I hope you are getting my point. Then we have classes of data. Data can be classified into two major categories: qualitative data and quantitative data. Qualitative and quantitative. Qualitative is something that you just use to, it's like you can only, you can rate them. You cannot quantify it. You can only rate it. Like 5-star rating, excellent, very good, poor. It doesn't have actual number. You can only rate it. That's ordinal data. Then we have nominal data in terms of color, no order. E.g. color, you can pick any color. Then when we talk about qualitative data, we have two types: discrete data and continuous data. So the continuous data is a set of data that is said to be continuous if the values belonging to the set can take on any value within a finite or infinite interval. Within a finite or infinite interval. Okay. Then we have a discrete value. discrete data. A set of data that is said to be counted, that is said to be discrete, if the values belong to the set of distinct and separate, that is, you can count them. You can count them. But continuous data, you cannot. You can only measure it. You can only measure it. You cannot count it. You can't count rice. You can't count beans. You can't count all those things, but you can measure it. You can measure sugar. You can measure cement. All those things, you can measure it. For discrete data, you can count it. What is the population of Nigeria? We have over 200 million. You can count it. Are you getting my point? Hello? I hope I'm not.
We are together. We will.
Yes, we are with you.
Yes, we are here.
Beautiful.
Yes,
We are with you.
Okay. So we have types of data: structured data, semi-structured data, unstructured data. Data that is processed, stored, and retrieved in a fixed format. Data that is processed or that can be processed, that can be stored, that can be retrieved in a fixed format. If you have your data, like e.g., for example, employee details, sales details, other details, they are structured. They are structured, they can be processed, they are stored, they can be retrieved. That's a structured data. Then we have semi-structured data, data that contains both structured and unstructured formats, like CSV files. CSV files. CSV means comma separated values. Comma separated values. We'll be working on a whole lot of comma separated values. We'll be working on all of that in Excel. Comma separated value, XLSX. That's Excel. We'll be working on that a whole lot. Then the third types of data is unstructured data. Data that lacks a specific form or structure. Emails, for example, it can come in any format. The person that wants to send mail doesn't care about the structure and all that. The person can just send a mail as long as you can understand the message the person is passing across. Are you getting my point? Three types of data: structured data, semi-structured data, and unstructured data. Data that can be processed, stored, and retrieved are called what? Structured data. Semi-structured data are data that contains both the structured and unstructured formats. Then unstructured data, data that lacks a specific form or structure. Now, this images talks about structured, unstructured, and semi-structured. If you look at the structured data, it is in a specific format. It's usually in rows and columns. Structured data is usually in rows and columns. Look at semi-structured data. It is combination of unstructured and structured. Look at the second column. It is structured. The last column too, the fourth column, it is structured. But unstructured, none of the stuff is structured. So these images tell us more about, give us the pictorial structure of different types of data: structured, unstructured, and semi-structured. Then we have types of big data. Even in big data, we have structured, unstructured, and semi-structured. So big data, it's another topic for another day. So we can, in form of big data, we can have audio, we can have video as well. So let's just move on. So structured data, define data types, most often quantitative data, easy to organize, easy to search, easy to analyze, stored in relational databases and warehouses, contained in rows and columns. Examples: Excel, Google Sheets, SQL, customer data, phone records, transaction history. All these are qualities of structured data. Then qualities of unstructured data. It's varied in data types. When we get to SQL, you understand the meaning of data types, because we'll be dealing with it when we get to SQL. Just don't worry. The data type is varied. It doesn't just accept one data type. The data types are varied. Then most often they are qualitative. They are difficult to search. They provide more freedom for analysis. It is stored in data lakes, data warehouses, and no SQL databases. No SQL database means not only SQL. Not only SQL. So when we get to SQL, we talk more on this type of database. So can't be put in rows and columns because it is not structured. If it is a structured data now, you can put it in rows and columns. Then examples: text messages, social media comments, phone call transcriptions, various log files, images, audio, video. Unstructured data belongs to no SQL because it doesn't have a particular order in which it stores its data. So structured data against or versus unstructured data. It can be displayed in rows and columns and relational databases. Like we said earlier, they are of numbers, dates, strings. Numbers, dates, strings. They are kind of data types. We are going to deal with all of that when we get to SQL. Then estimated 20% of enterprise data. That's from Gartner. It's a kind of research through Gartner. That requires less storage. It is easier to manage and protect with legacy solutions. Now, unstructured data cannot be displayed in rows, columns, and relational databases because it is unstructured. It can come in any format. Then they are usually in images, audio, video, word processing files, emails, spreadsheets. And the kind of spreadsheet we are talking about, it's not in megabytes. If it's going to be in megabytes, it's going to be in like 500 megabytes, 1 gigabyte, and above. Then estimated 80% of enterprise data that are unstructured it is unstructured data. It is estimated to be 80% of enterprise data. It's also a research from Gartner. Then requires more storage. It requires more storage. Like some of us, when we first bought a laptop, the only thing we use our laptops for is to watch movies in those days. And if you check quite often, we have lots of movies. Before you know it, the hard drive is beginning to get filled up. So it requires more storage. Then it's more difficult to manage and protect with legacy solutions because they are in various types of data. Now, data formats in practice. We have internal, we have external, primary data, secondary data, qualitative, quantitative, nominal. We've talked about this. We talked about this earlier. Then primary versus secondary data. some of us that have worked in a research company, we understand this stuff I'm trying to talk about now, primary and secondary data. Primary data is collected by a researcher from first-hand resources. I remember when I was working on my project in University of Ibadan, I did statistics from University of Ibadan. I was asked to prepare a questionnaire, and I went inside Agbowo to collect my data, which I had to translate it, analyze it, and all that, and I use it for my project. So the data that is collected by researcher from first-hand resources, whether through interview, whether through questionnaire, they are called primary data. Data from an interview you conducted, data from a survey returned from 20 participants, data from questionnaires you got back from a group of workers. All these ones are primary data. Good. Now, secondary data, gathered by other people or from other research. Probably like a data you get from CBN, data you get from the internet, data somebody had worked on. All those ones are what are secondary data. It's not, you are not the one that gets that data directly. Data you bought from a local data and analytics firms, customer profiles, demographic data collected by university, census data gathered by the federal government. So all these data are what are secondary data. The data that you are not the one that collected it. So it is called a secondary data. So we have internal data and external data. Internal data, data that lives inside a company's own systems. Wages of employees across different business units, tracked by the HR. Sales data by store location. Product inventory levels across distribution centers. Internal data, these are data within an organization. Then external data, data that lives outside of a company or organization. National average wages, credit reports for customers of an auto dealership. So it's like internal and external. Internal data within an organization, external data that lives outside the company or organization. Continuous against discrete data. Data that is measured and can have almost any numeric value. That's continuous data. It can be measured and it can have almost any numeric value. Example, height of kids in third grade classes, 52.5 inches, 17 inches, 65.8 this inches, in centimeters, in meter, like that. The wrong time markers in a video. Then temperature, those are what continuous data. If you notice the continuous data, they have decimal places. They have 52 point this, 73 point this, 5 point this. Those are continuous data. So discrete data, data that is counted and has a limited number of values. Data that is counted and has a limited number of values. Number of people who visit a hospital on a daily basis, 10, 20, 200, 1,000, and so on and so forth. Rooms maximum capacity allowed. Tickets sold in the current month. The number of people that entered the elevator, and so on. Qualitative and quantitative. Qualitative and quantitative. Don't worry, we are going to understand all this by the time we start our analysis. It's not all of them we are going to make use of. but we just need to have an idea of different types of data that we have. So qualitative data, subjective and explanatory measures of qualities and characteristics. Subjective and explanatory measures of qualities and characteristics. Example, exercise activity most enjoyed, favorite brands of most loyal customers, fashion preferences of young adults. Quantitative, specific and objective measures of numerical facts, percentage of board certified doctors who are women, population of elephants in Africa, distance from Earth to Mars. These are quantitative types of data. Nominal versus ordinal. Nominal is a type of qualitative data that is not categorized with a set order. It is a type of qualitative data that isn't categorized with a set order. Example, first-time customer, returning customer, regular customer. The next one, new job applicants, existing applicants, internal applicants, new listing, reduced price listing, foreclosure. The next one is ordinal type of data. A type of qualitative data with a set order or scale. This is usually rank, movie ratings, income level. So these are type of ordinal data. So we are coming back to our structured and unstructured data. These are major two types of data that we have. Structured data, data organized in a certain format, like rows and columns. We've been talking about this often. Expense reports, tax returns, store inventory. The unstructured data, data that isn't organized in any easily identifiable manner. Social media posts, emails, videos, audios, images. Those are types of unstructured data. Now, excuse me, data set versus database. Like I said we'll be taking it one step at a time. We've talked about data. What is data? The type of data that we have, classes of data, and we've been able to talk about them. So a data set against database. What is a database? What is a data set? A data set is a collection of data, usually presented in tabular form. A data set is a collection of data, usually presented in tabular form. If you check the working file I sent, there's a particular sheet there that I put, I think data set or something. You see that it's comprised, it's in a table. It's in a table. I think, I can't remember precisely now. I think it's like an other data set. And we are going to work with that data set for a lot of stuff. So a database is an organized collection of data for one or more purposes, usually in digital form. Data set is a collection of data presented in a tabular form. Database is an organized collection of data for one or more purposes, usually in digital form. Database, you don't usually see database. It is a back end, but with the help of SQL statements, you can view it. Though it's a database, also it's in a tabular form. It's in rows and columns. So we see all this as time goes on. Then we have what we call metadata. Metadata, a set of data that describes and gives information about other data. A set of data that describes and gives information about other data. If you look at this picture, if you look at this image, or when you have any image on your phone, probably somebody sent something to you on WhatsApp, and you want to check the details of that image sent to you. Most of us do it. We click details, probably want to check the size. Some of us want to check the size, the time, the date, the format, and the path. So a metadata is a set of data that describes and gives more information about other data. So all this info on this image, they are the metadata of this data, which is the image. We have big and small data. As a data analyst, you will work with both big and small data types. Data. Let me put it that way. Both kinds of data are valuable, but they play different roles. They play different roles. Small data and big data. Whether you work with big or small data, you can use it to help stakeholders. You can use it to help stakeholders improve business purposes, answer questions, create new products, and more. Let me just say this. Excuse me. The essence of data analytics is to draw inferences, from data, to gather more information about the data, then to advise business owners, to help them to improve their business processes, to help them answer some questions. By the time we start to work with some data set, then we will get to know more about this fact. So we have small data, we have big data. Small data describes a data set made up of specific metrics over a short, well-planned, well-defined time period. It's usually small. Based on its name, small data, it's small. Then it's usually organized and analyzed in spreadsheets. Any data you see in spreadsheets, it is small data. Spreadsheet data, small data. Likely to be used by small and mid-sized businesses. Simple to collect, simple to store, to manage, to sort, and visually represent. It is usually already a manageable size for analysis. Like one of the sheets, the one I sent, it is in a manageable size for analysis. I downloaded a file sometimes ago. Even my Excel could not load it properly. I had to use Python to load it because it was heavy. Though it was a CSV file, it was heavy. Then big data describes large, less specific data sets that cover a long period of time. You can imagine if you enter a park, let's assume Baga Park, and they said, okay, tell us how many number of vehicles have been loading in that Baga Park since maybe about 10 years ago. So you can imagine the volume or the size of that data. Then it is usually kept in a database and queried. They usually have it in a database. So you can't have it, you can't have it physical, though you can retrieve, you can query it, view it, and extract part of it because it is usually heavy. Likely to be used by large organizations. It takes a lot of effort to collect, store, manage, sort, and visually represent. Then the last one usually needs to be broken into smaller pieces in order to be organized and analyzed effectively for decision making. Now, we are using style to talk about big data. And that's not where we're going, but we just have to have an idea of what it is. So we have 4 V's of big data: volume, variety, velocity, and veracity. This is 4 V's of big data. Volume is the amount of data, the variety, different kinds of data, velocity, how fast the data can be processed, then veracity, the quality and reliability, how reliable the data is, the quality of that data. These are all the 4 V's of big data. Then we have data life cycle. Data life cycle. Data life cycle describes the path data takes from when it's first generated to when it is interpreted into actionable insights. If you look at the chart, we have 1, generation, 2, collection, 3, processing, 4, storage, management, analysis, visualization, then interpretation. These are this is the data life cycle. 1, 2, 3, down to 8. This life cycle can be split into 8 steps: generation, collection, processing, storage, management, analysis, visualization, and interpretation. We'll be working with some of them. We can do the collection, we do processing, we do analysis, we do visualization, and we interpret. Now, data privacy and ethics. Data privacy and ethics. I got some jobs online, some adverts online, but once they know that you are you are based in Nigeria, they don't want to release their data for you to work with. They won't want to release their data because of data privacy. So data privacy, also known as information privacy, is a subcategory of data protection that encompasses the ethical and legal obligation to protect access to personal identifiable information, PII, which is any information that can be linked to a specific individual. If you notice, if you are filling any form online, they always put data protection, that your data cannot be given out without your consent, like that. So why do we think Facebook gives us free accounts? Why do we think Yahoo, Gmail, they give us free accounts? They are using our data. You be thinking, I have a free account. I can use my Facebook anyhow. I can use my Gmail. I can use my Yahoo Mail. I can use Hotmail free. Meanwhile, they have some specific ones that are not free, that you have to pay. But the one that we are buying free, you'll be wondering, how come WhatsApp is giving us for free? How come WhatsApp it's giving us the WhatsApp for free? How come we are having some apps for free if they're not getting anything from us in return? They are using our data without we knowing. So some examples of PII include full name, address, SSN, that's social security number, and passport number. So we have general data protection regulation. So data integrity is the accuracy, completeness, and quality of data. And it is maintained over time and across formats. Preserving the integrity of your company's data is a constant process. Data integrity, that means your data must be protected. You must keep the integrity of the data intact. Nothing must happen to the accuracy. It must not be removed. Nothing must be added. It must be complete. The data must have good quality, and it must maintain over time and across formats. Okay, threats to a data set integrity. These are the threats to data sets integrity. human error, inconsistency across formats. Human error, for instance, accidentally deleting a row of data in a spreadsheet. Inconsistency across formats. For instance, a data set in Microsoft Excel that relies on cell referencing may not be accurate in a different format that doesn't allow those cells to be referenced. So that's inconsistency. Collection error. Data collected in inaccurate or lacking information, creating an incomplete picture of the subject matter. Cybersecurity or internal privacy breaches. For instance, someone hacked into your company's database with the intent to damage or steal information, or an internal employee damages data with malicious intent. These are all threats to data set integrity. Then to maintain your data set integrity, diligently check for errors in the collection, formatting and analysis phases. Monitor for potential breaches and educate your team about the importance of data integrity. Now, these are the steps in data analytics. You ask questions, you prepare the data, you process it, you analyze it, you share it, then you act on it. Don't worry, we see all of this in play. We see all of this in play. So let me quickly rush over the second one, the second slide, which is an introduction to data analytics. I may just rush through this. I'm hoping that we have enough time to work on maybe one aspect of our Excel, or probably I may give us use the first sheet and the second sheet, give it to us as a homework. It's not something that is very difficult. Every day, the amount of data out there gets bigger and bigger. So the ability to interpret it effectively is more important than ever before. So data analytics is becoming one of the fastest growing and most rewarding career choices in the world. I said something the other time that as long as the earth remains, we must have data. So data analytics is not something that is going out of, it's not something that is going out. Sorry, it's not going something that is going to fizzle out any from now. As long as the earth remains, you must have data. And that's where you see that it's becoming one of the fastest growing and most rewarding career choices in the world. Data analytics, business analytics, data engineering, data science, business intelligence, and host of others. So all kinds of companies all over the world need qualified data analysts to solve problems and help them make the best possible business decisions. That's the whole essence of a data analyst. You help them to work with their data and you help them make the best possible business decisions. As long as the data is accurate, you can help them to make best business decisions. What is data analytics? What is data analytics? Data analytics is the science of extracting trends, patterns, and relevant information from raw data to draw conclusions. It is the science of extracting the trends, patterns, relevant information from raw data and draw conclusions. So data analytics is the process of examining and analyzing raw data sets. To do what? To draw conclusions, to derive more information, to improve businesses, products, and services. So data analytics is termed as the process of extracting meaningful insight from data, such as hidden patterns, market trends, and customer preferences. This is done by studying and analyzing the procured data. Let me just throw more light to this. If you notice, or we may not be, some of us may not be aware, before any new product come out, they must have done their analysis very well. I remember one of my aunts used to work in a research company. Before Origin came out, they gave them that job to do research on it, to ask people what do they want? What do they want? If you notice, they put honey in Origin instead of sugar. They put honey in Origin. The one can, maybe Origin 0 or something, they put honey in it. So they made a lot of research, and from their research, they know quite all right that they can make money, that they won't run at loss from that research. So data analysis helps businesses. It helps them to check the trends. It helps them to check the trends, to check the hidden patterns, and ask for customer preferences. What do you like in your drink? What are the things you don't like in your drink? And by getting all those data, by putting them together, they can help the company to help them to work on preferred products. So data analytics, the benefits of data analytics, it helps us to reduce costs, effective decision-making, improved efficiency, good resource utilization, good market insights. These are the benefits of data analytics. So our company uses data analytics. How Amazon uses data analytics. Some of us will be surprised. Some of us that if you have bought anything on Jumia, even if you are not doing anything with Jumia, even if you are on Google, Jumia advert will pop up, and they will start to show you all sorts of things similar to what you bought before. It is the same way Amazon uses data analytics. Look at the first one. Gathers customer data while they use the site. Can you imagine? Tracks what they buy and their shipping address. Compares products they browse. Even if you're not buying, they try and check what you check. The kind of products you always browse about. Maybe if you are the type that loves phone, if you are the type that loves shoes, they check the kind, the brand. It could be Nike, it could be Adidas, it could be Puma, it could be, they know the kind of brands you want. So they now gather all those information, they recommend products to you based on your needs. Then build your profile with available data. Then they suggest products bought by similar customers. If they have similar customers, suggest products bought by similar customers, build profile with available data, and recommends products based on needs. So they start to push it to you, even if you don't want to buy. Oh, I like this. It seems this is nice. Okay, I like this. So that's how they use data analytics. So Amazon decides what you want to buy based on your profile, offers you what similar profiles you have purchased. If you have bought something on their site before, they offer you something similar to what you've bought. Then likewise, Netflix. If you have watched movies, if you have browsed some of the movies, if you have subscribed to some of the movies, they give you similar ones. If you are the one that likes action movies, they push it to you. If you are the one that likes drama, family movies, romance, love and romance, they push all of those stuff to you because you've subscribed to one of them before. We have a case study of Microsoft. how Microsoft used data analytics to cut costs and improved collaboration and productivity. A technology giant, Microsoft, collaboration is key to productive, innovative work environment. Following a 2015 move of its engineering group's offices, the company sought to understand how fostering face-to-face interactions among staff could boost employee performance and save money. So what they tried to do was they tried to like collapse one of their buildings, like what some people are doing now. They will just tell you work from home, and they try to reduce the bill, the cost in which they pay for the building. If they are using the old building, maybe like 5 floors, they can collapse it to just one floor, and they will ask everybody work from home. Maybe you come to the office one day and give reports. Like this, Microsoft Workplace Analytics team hypothesized that moving the 1,200 person group from 5 buildings to 4 could improve collaboration by cutting down on the number of employees per building and reducing the distance that staff needed to travel to meetings. So with this, they cut down the cost. They reduced the size of building they are using, and they reduced the number of staff that come to work. It was from their workplace analytics team that suggested that to them. So at the end of the day, it saved them $520,000 per year in employee time. So it saved them so much. So data analytics can help you to reduce costs and help you to reduce your customer preferences. So they use data analytics in healthcare too. Healthcare industry is one of the most promising areas where data analytics can be applied. We have it in all sorts, finance house, healthcare, and what have you. So it reduces cost of treatment, avoids preventable disease, predicts outbreaks of epidemics, improves quality of life. During the pandemic, that was when the world knew that they didn't have data. So it took them some time before they could come up with sizable data that they can work with, that they can analyze for them to have good results, for them to stop the epidemic. So government to use data. Government makes vital decisions based on the information received. It is difficult to verify the information, and faulty data can have negative consequences. And that's one of the things I told us the other time, that if it takes us 70% of the time we have at our disposal to work on our data, excuse me, that we should just give it to our data and make sure that we clean our data, because faulty data can have negative consequences. Because if your data is not well cleaned and you process it like that, it's not going to give you the accurate results that you are expected to work with, because it's going to affect your decision. It's going to affect the kind of advice, the kind of recommendation you need to give to your clients. Government use data analytics to help in welfare schemes and cybersecurity. So difference between data analytics and data science. While data analysts and data scientists both work with data, the main difference lies in what they do with the data. Data analysts examine large data sets to identify trends, develop charts, and create visual presentations to help businesses make more strategic decisions. While data scientists, on the other hand, design, construct new processes for data modeling and production using prototypes, algorithms, predictive models, and custom analysis. This is more of programming. Don't worry. So we have job opportunities in data analytics, like career path in data analytics. Okay, before then, let's see why choose. Why do you want to choose, or some of the reasons for you to choose a career in data analytics? There are quite a few practical reasons a data analytics career might be appealing. This includes very high average salaries, fast-growing industry with skilled workers in demand, lots of room for career advancement, wide variety of available roles in the field, very few mandatory qualifications, lots of great learning resources. So these are the practical reasons. These are the practical reasons you have to develop to choose a career in data analytics. So these are the job opportunities or career path: business intelligence analyst, data analyst, operation analyst, people analyst, marketing analyst, financial analyst, project analyst, technical analyst, program. It's endless. It's endless. Now, salary of a data analyst, according to Glassdoor, very high confidence. You can Google this. So a data analyst, a professional data analyst, earn about $70,000. Minimum average of 69,517. Sorry, can that person mute his mic, please? Can I mute the person from here? Check the person. Try and mute the person. Okay, I think the person has. Okay, let me continue. So it is the salary of a data average of 69,000 US dollars. That's how much? 3.2 million naira per month in naira. So 38 million. So if you're a professional data analyst, you can earn as much as this. Now look at this. At least this is from Nigeria. 2 million per year from Access Bank, 3 million per year from Globalcom. Then Fidelity Bank, 216,800 per month. Then Ash Analytics, 400,000 per month. Zenith Bank, 618 to 672. Andela, 287. Deloitte, 145 to 157. So these are the types of data analytics. There are 4 key types of business analytics. Business analytics is it's embedded in data analytics. I think I have a small write-up that tells us the difference between data analytics and the business analytics. So if time doesn't permit us, I will send it to us in the group. So descriptive analytics is the interpretation of historical data to identify trends and patterns. That is, we want to get the trends and pattern. During the course of our analysis of our data visualization, we are going to work with trends. We are going to work with trends in the sense that we want to compare. Let's assume that I want to get the trends of a revenue generated by the particular company. So we want to compare maybe from January to December. So what is the flow? How does it move? Are they making profits? What happened when in a particular time the revenue goes up, and in a particular time it comes down and all that? So that's descriptive analysis. Then predictive analytics. Why predictive analytics centers on taking that information and using it to forecast So predictive analysis is you use the information that you gather to forecast the future outcomes, like time series. For some of us that have a statistics background, you use time series to forecast. Then we have diagnostic analytics. It can be used to identify the root cause of a particular problem. Then prescriptive analytics. In case of prescriptive analytics, testing and other techniques are employed to determine which outcome will yield best results in a given scenario. You want to check what is okay. Like in Excel, we have what we call scenario manager. Scenario manager can help us to do this. So if I have 1,000 naira today, and I change the job and all that, what happens? Which is the best scenario? What will give me the best results in a given scenario? So this is 4 main types of data analytics. Descriptive tells us what happened. Diagnostic tells us why did this happen. Predictive, what will happen. Forecast, want to forecast. Prescriptive, how can we make it happen? How can we make it happen? See, this is end of. Do we have any question before I come up with okay, I have this. I give us a data set. Then do we have any question, please? Hello? Have I been talking to myself?
Yeah. Hi.
Okay.
Hi.
So sorry. I'm just trying to run through that slide so that you have an idea of where we are going into. It's a journey. It's a journey. So we are going somewhere. Don't worry. So from the analysis of the form signed up, we only have few people that are new to Excel. Only few people, maybe about 2 or so out of all of us. That's like maybe 10% or 5% out of all of us. So what I want us to do is this. I'm still going to treat this, but I want to give us this as an assignment. I know we get it. I want to give us this as an assignment. This is these are the questions. These are the questions. Fill in all the blank spaces using the percentage of basic salary to get the health insurance, transport, feeding, housing, and tax. Hello?
Hi.
Okay. Good. Are you getting my point?
We are hearing.
Okay, beautiful. So this file, you use the basic salary to get the health insurance for Buhari, Yemi, Babatunde, and the likes. Lai, Mohammed, Oluseyi, Abiodun, Oluremi, all of them. So 8% of their basic salary is for the health insurance. 5% is for the transportation. 5.5 is for feeding. 12% is for housing. 7.5% is for tax. Then you get the total. And when you must have gotten that, you get your total here too. Then you find your minimum. You find the maximum. Then you find the average. I know somebody will shout, but I asked you for formula for finding average the other time, you didn't tell me. Don't worry, let me just show us. Minimum, what you just do is this. Minimum is equals to mean Then you get all the values. You can see number 1, number 2, you get all the values. Then you close the brackets. By the time you hit enter, so it's going to give you your, okay, let me just do that. Let me just do that. Like this. So it's going to give you your minimum. That's the minimum. Then this is maximum. So that's the maximum. Then your average. So that's the average. So I'm going to remove it because I've given you a redo. So any question? Now, after this first one, then there's another one, the second one. I want you to look at this and give it your best shot.
Okay.
We don't have much here. We don't have much. We only have 29 rules. So what you're going to do for me is you list out all those countries here. Then you add their total revenue in front of each one of them. Okay, for example, let's assume USA. USA appears quite a number of times. So you get USA's revenue, all of them put together. You put the value here. Let's assume that USA has the first one. Let's assume the first one is 5,000. The second one is 1,000. So you sum all of them together using formula. So all of them, let's assume that it is 30,000. So you sum it here. Not that you just write 30,000. I want to see that formula. Okay. Likewise, Switzerland, Austria, UK, and a host of others. Then 2, you count the number of times those countries appear. You count the number of times they appear. So you put them here. Hello? Any question before I call it a day?
Sorry, I got logged out just before you started treating this Excel sheet. And I just got back in now. So I'm studying.
Where?
Basically, I didn't start this Excel sheet with you.
Okay, I'm not treating it. I'm giving it to you as homework.
Okay.
Okay. So
can you run it again?
I only gave them info on how to find minimum, maximum, and average. You get?
No, my
so
Olamide is looking for Expo. We don't give Expo yet.
So your basic salary, the basic salary of all these guys, 8% of this basic salary is for health insurance, 5% is for transportation, 5.5 is for feeding, housing, 12%, tax, 7.5, then you get the total. Are we good? Hello?
Yes.
Okay, beautiful. So can we call it a day?
So the assignment, how are we going to present it?
Don't worry, just do it. Do it. I will
Okay,
call
just
for
do
it.
it.
Don't worry. I'll call for it.
Okay.
I'll call for it. Don't worry. And each time you do it, I will try and.
Please, are you going to send the Excel to our? Can you send the Excel to the WhatsApp?
I've sent it already. I've sent it long time ago. I sent it earlier this afternoon. Then I sent it again when I added Olamide to the group. I resent it. So I sent it twice to the group.
Okay. Sorry, quick one. So for these assignments, we just to find the mean, right? For the basic salary. Is that it?
So for all of them.
For all of them, all these columns.
Okay.
The questions are here. Look at the questions.
Okay.
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 Beautiful. Okay.
All right.
Any other thing, please?
I think from my side, I think I'm okay.
Okay, okay. So I can stop recording, right?
Yeah, I think you can.
All right. Can we call it a day? Or we have any other person that has a question? Do we have question, please?